Hi everyone, welcome to Smart Math Online Tutor. Through this video, I'm going to help you get a quick revision on how to answer questions on the theme measurements. Before going to the questions, let me give you an idea about the types of questions you may get for your final paper under this theme. Do you know that 15% of your paper includes questions on the theme measurements? One question is probable in part B of the first paper of your O-level exam. And at the same time, two questions are probable in the second part of the paper. The theme measurements includes perimeter, area, volume, and trigonometric ratios. Through this video, we are going to pay our attention to questions related to perimeter and area which are probable in part B of the first paper. So let's get started. The first question says ABCD is a rectangular plot of land owned by someone. A vegetable is grown in the shaded area which is a sector of radius 7 meters. So the first part of the question says us to find out the curved boundary of the section where the vegetable has been grown. You know, to find the curved boundary of a circle, we should apply the equation circumference equals to theta over 360 degrees into 2 pi r. By applying this equation to this shaded region where the theta is 90 degrees, we get the answer as 11 meters. The second part of the question is to find out the area in which the vegetable is grown. That is, we have to find out the area of the shaded region. Just like before, we apply the equation of area of a sector, that is theta over 360 into pi r squared. So by applying this equation, we get the answer as 38.5 meters squared. The third part of this question says us to find out the area of the remaining part where vegetable is not grown. To do this part, first of all, we have to find out the area of the total rectangular plot. We know rectangular plot's area can be found by length into breadth. You have to multiply. So that gives us 280 meters squared. And by subtracting the shaded region, you get the remaining area as 241.5 meters squared. The last part of the question says that someone plans to separate out a right angle triangle plot of land so that its area is 3 times the vegetable grown area. If BC is to be one of its boundaries and the other boundary is to lie on DC, we have to sketch the plot of land that can be separated on the diagram with measurements. So first of all, to do this part, we have to find out the area of the rectangular plot he is planning to separate. It says that is 3 times the area of the shaded region. So what we do is we multiply the area of the shaded region, that is 38.5 meters squared, by 3 to find out the area of the rectangular plot, that is 115.5 meters squared. Right, now we know the area of the rectangular plot. We know BC is one of its boundaries, so let us take it as the height of the triangle, and we are going to find out the length of the base of the triangle that lies along BC. So what we do is we have to apply this area into the equation of area of a triangular plot, that is half into base into height. Let's take the base as BC and height as x, and x lies along the side BC of the rectangle. Once when you apply this equation and when you subject x, you get that x is equal to 2 times 115.5 divided by 14, that is 16.5 meters. So along DC line, we have to mark 16.5 meters and draw the triangle like this. Let's move on to the second question, children. Here another diagram is given that is supposed to be a wall hanger which contains a semicircular part and a triangular part in a rectangle PQRS. So the first part is, what is the perimeter of the semicircle? Semicircle, you know, perimeter of a circle is 2 pi r. Therefore, the semicircle will be pi r. Applying this equation and substituting, we get the length of the curved part of the semicircle is 22 centimeters. But to this, we have to add the diameter as well. So we add 14 to that, and then the final answer is 36 centimeters. The second part of this question tells us to find out the area of the semicircular part A. So you know area of a circle is pi r squared. Semicircle will be pi r squared by 2. So we apply this, substitute the values, and the answer is 77 centimeters squared. The third part of the question tells us to find out the ratio of the areas of parts A and B. To do this, first of all, we have to find out the area of the part B. B is a triangle. You know area of a triangle is half into base into perpendicular height. So half into base is 14 and height can be taken as 7 centimeters. So once when you multiply, you get the answer as 49 square centimeters. That is the area of the triangular part. But we need the ratio. So when we write the ratio, it will be 77 is to 49, but we need it in the simplest form. You know both 77 and 49 can be divided by 7. So the simplest ratio between the areas of A and B is 11 is to 7. The last part of the second question tells it is required to add a rectangular band which is equal in area to the part B to the wall hanger. Draw with measurements in the diagram how this band can be added with PS as a margin. So if PS is a margin, the length of the rectangle will be 14 centimeters. We have to find out the breadth. So since the area is known to be 49 square centimeters, we can find out the breadth easily by dividing the area by the length. That is 49 divided by 14, which gives us 3.5 centimeters as the breadth. So taking 3.5 centimeters as the breadth and PS as the length, you can draw a rectangular band like this. Make sure you mark the breadth clearly. So it will look like this. Here is the third question. A square-shaped exhibition camp was constructed on a circular plot of land of 70 meters of radius. The land is divided into 4 equal parts as shown in the diagram. So the first part tells us to find out the angle of AOB. You can see that ABCD is a square. You know when diagonals of squares intersect one another, they intersect at perpendiculars. So the angle AOB is equal to 90 degrees. The next part of the question tells us to find the area of the sector-shaped plot AOB. So we have already learned how to find the area of a sector. In this case, AOB is a quarter circle. So I divide the area of the circle by 4. So by applying this equation, you get the area to be 3,850 meters squared. The next part is to find out the area of the triangle AOB, and that is half into base into the perpendicular height. So here you should clearly understand AOB triangle is a right angled triangle because the center angle is 90 degrees. So we can take one side or one radius as the base and the other radius as the height. So our answer becomes half into 70 meters into 70 meters, that is 2,450 meters squared. The fourth part is to find the area of the shaded part that is not belonging to the camp. At the beginning of the question, we understood that the square is the camp and the part out of the square is not belonging to the camp. So we have to find out the shaded area of the shaded region. Already in the previous questions, we found out the area of the sector and area of the triangle. By subtracting the area of a triangle from the area of the sector, we can find out the area of one small shaded part. So that is 1,400 meters squared. There are 4 such small shaded regions. So we multiply that by 4 in order to find out the total shaded area. That is 5,600 meters squared. The last part of the question tells us to find out the perimeter of the shaded part of the sector. That is the small shaded region we have to find out. So first of all, let's find out the arc length. Since this sector is a quarter circle, you can apply the equation for circumference of a circle, that is 2 pi r divided by 4. So by applying the equation and substituting the values, you get the arc length as 110 meters. And when you consider this triangle AOB, we know AO and OB are the radii of the circle, so both will be 70 meters each. We need to find x. That length x can be found using the Pythagoras theorem. So since they have given to take root 2 as 1.4, so by applying Pythagoras theorem, you can find out the value of x to be 98 meters. So this 98 meters plus the arc length 110 meters altogether gives you 208 meters. Moving on to the fourth question over here, that says the diagram shows how a flower bed in the shape of a sector of radius 14 meters is divided into two sections. The first part of the question is to find out the perimeter of the flower bed. As we already learned, the perimeter is equal to theta over 360 degrees into 2 pi r. By substituting the values, you can get the answer as 22 meters. Along with the arc length, we have to add the two radii of the sector. So 22 meters plus 14 meters plus 14 meters will give you 50 meters as the answer. The second part of the question is to find out the area of the section A of the flower bed. Section A is a sector again, but the angle at the center is not known. But if you see carefully, if I extend this part like this, it is a triangle, and since both the sides are equal to 14 meters and 14 meters, it is an isosceles triangle. And since it is a right-angled isosceles triangle, the two angles opposite to the equal sides must be 45 degrees each. So the angle at the center of the section A is 45 degrees. Applying that to the equation of finding the area of a sector, we get the answer to be 77 meters squared. The third part of the question is to find out the area of the section B. Now, first of all, we have to find out the area of the flower bed. For that, we apply the equation of area to the quarter circle, and then you get the answer as 154 meters squared. From this, you subtract the area of the section A in order to find out the area of section B. So that gives you 77 meters squared as the area of section B. The last part of this question tells us that a rectangular block of turf is to be attached along the radius of section A and outside it, such that the length is equal to the radius of the section A and the area of the block is equal to the area of section A. We have to draw in this figure the sketch of this part that is to be attached. First of all, let us find out the area of the rectangle that is to be added. Since length is 14 meters, it is given. Let's find out the breadth by equating the area of this rectangle to 77 meters squared. So B is equal to area divided by the length of the side, that is 77 divided by 14, which is equal to 5.5 meters. So now what you have to do is to draw a rectangle at the base of this diagram like this with the breadth 5.5 meters. Here we go to the fifth question of this video. The sketch of a rectangle shaped netball court is given below. Fine. Then the first part of the question is to find out the perimeter of the netball court, which is very easy. This is a rectangle. Perimeter of rectangle is 2 times the sum of length and breadth, that is equal to 90 meters. Moving on to the second part, it is to find the area of the netball court. As you know, area is equal to length into breadth of a rectangle. So 15 meters into 30 meters will give you 450 square meters. The next part of the question is to draw a semicircular goal circle inside the court. The center P of the goal circle must lie at the midpoint of AB, and further the goal circle must meet AB line at the 2 points which are 2.6 meters away from A and B respectively. Draw a sketch of the goal circle on the figure and note its radius. So this is the figure, and once when you draw the goal circle, it will look like this. Let's mark the required distances as mentioned, 2.6 meters from both A and B, and P will be like this. Fine. Now the diameter of this circle must be found, but we know the total distance from A to B is 15 meters, and from that if we subtract 2 times the 2.6, then we get the answer as 9.8 meters. This 9.8 meters is the diameter of the circle, but we need to find the radius, so let's divide it by 2 and get the radius, and that is 4.9 meters, and mark it on the diagram like this. Moving on to the last part of the question, that is the 2 goal circles as mentioned in part 3 above are located on both sides of the netball court. If the center player is not allowed to enter the goal circles, show that the area in the court in which she can move is 374.54 square meters. So the diagram will look like this, and this shaded region is the region where the center player can move. First of all, let us find out the area of the 2 goal circles. Since both are semicircles, together if you take, it will be a circle. So let's find the area of the circle with radius 4.9 meters. Once substituted to the equation, you get the answer as 75.46 meters squared. This is the area of the 2 goal circles. In the previous part of the question, we found the area of the netball court to be 450 square meters. So if you subtract the area of the 2 goal circles from the total area, you get the answer as 374.54 square meters, and here we showed she can move in this given area. Hope I made myself clear on how to apply the theories of measurements in questions. See you with another Smart Math clip. Until then, goodbye.